Okay, so for problem number 1, we have 5, and then we have parentheses x plus 6, close parentheses, plus 2x, and it's equal to 16. So first question to ask, do we have distributive property? Do we have distributive property? Yeah, we do, right? We see the parentheses, so that means we know that there is going to be some multiplication going on. We know we're taking this 5 and multiplying it by the x, and taking the 5 and multiplying it by the positive 6. So I'm going to write that I am doing 5 times x, and I am doing 5 times 6. Okay, when I do that, that's going to give me 5x, and it's a plus 30. Okay, so I used all of this information, but I still have other stuff that's left over, so that needs to come straight down, right? We still have a plus 2x and an equal 16. That needs to come down into the problem. Okay, next question to ask. Can we combine any like terms? Coven? Yeah, what can we combine? Good, we can combine 5x and we can combine 2x. Okay, so we can do 5x plus 2x, which is going to give us 7x. Now we still have information that needs to come down. What else still needs to come down, Nihat? Okay, plus 30. Anything else? Equal 16. Okay, so we still have this information here. I'm going to go ahead and rewrite that over here because I ran out of room. All right, from here it's now just a two-step equation, so we need to go ahead and do what first? What's the first inverse operation that needs to happen, Jacqueline? Make it a minus 30. So we're going to make it a minus 30 under 30. Where else do we have to make it a minus 30? Under the 16. Okay, you got to make sure you're doing it in both spots, because we know by doing it here, we can then cross it off, right? We can get it, we can cancel it out. Yes, dear. Oh, okay, what is that? Negative 14. Good. So we get 7x is now equal to negative 14. That's our new equation that we've created. Okay, from here, what's our final step to solve? Rajay? Okay. And what are we dividing them both by? By 7. Right? We're dividing both of these sides by 7. So the 7s can then go ahead and get canceled off, and we get x is equal to negative 2. Did you have a question? Do you have a question? You good? I'm waiting. You good? Okay. All right, let's take a look at the next problem here. Next problem here, we have negative 4/9 is equal to 5/18 x. I don't like that. Why don't I like it? What's wrong? Something's glaringly wrong here. Giancarlos? It's supposed to be reversed, right? We got to do that rewrite. Okay? If the variable's not on the right, if the variable's on the right, then we do a rewrite. We just flop the sides. That's all we do. We're not changing the order of anything. We're just flip-flopping our sides. Okay, everything else is still exactly the same. Okay, do I have any distributive property? No, there's no parentheses. Do I have any like terms that I can combine? Nope, no like terms I can combine. Do I have a constant here? No, there is no constant, right? Constant would be a number by itself with the x, right? Cover up that side. There is no constant. Do we have a coefficient? Yeah. The coefficient is 5/18. Now, just because it's a fraction, a lot of people think, oh, it's a fraction, I must multiply. That's not what we're doing, because the fraction is being multiplied with the variable. It's side by side. If it's side by side, we divide. Keep that in mind. I'm always trying to come up with rhymes for you guys because I feel that helps. If it's side by side, then we divide. That's what we're going to do. We're going to divide both sides by 5/18. So that means we have to divide negative 4/9 by 5/18. Guys, if you set it up and write it exactly like we see it, then when you type it just like this into your calculator, negative 4/9 over 5/18, it will divide it for you. Okay, it'll do a natural divide for you. and you'll get x is equal to negative 8/5. When they're side by side, we divide. All right, number 3. Yes, dear.
Is it the same thing we get -1 and 3/5?
Yeah, -1 and 3/5 is fine too, but what I want you guys to start getting used to is leaving them in improper fraction form, because it's going to lead us into one of our units, our future units, where you're going to not have mixed numbers anymore, you're going to have improper fractions. Okay? If it's a word problem, then yeah, you would want to convert it, but get used to the idea of improper fractions being acceptable. All right? All right, number 3, for problem number 3, do we have distributive property? Yes, we do. We can take that -4 and we can multiply it to 3x. And then we can also do -4 and multiply it by -2. Okay? Do not forget that that 2 is a -2. Okay, that's going to give us -12x and +8 or +8. Okay, and we still have it set equal to -76. Do we have any like terms that we could combine together here? No. Right? We have a variable. We don't have any other variables. We have a single constant on the side. There's no more constants on the side. So we cannot combine any like terms. All right, what's our first inverse operation that needs to be performed here? Noah? Negative what? -8. Or instead of saying -8, because it is an operation, we are subtracting 8. So we're going to subtract 8. We're going to subtract 8 from both sides. We can box it and cross it now. Okay, so what are we left with? What is our new equation going to be here? Coven? Good. -12x is equal to -84. Okay, and then our last step, our very last step. Addison? Wrong order. -84 divided by, because remember, let me tell you what you just said. You said -12 divided by 84. This is what that looks like. -12 divided by -84. You're going to get a decimal or a fraction. Okay? Yeah. Yeah, by -12. Good. You have to make sure you're dividing in the correct order. We're going to divide both sides by -12. Has to be by the negative because we want to get rid of the negative as well. Okay, a lot of mistakes come where people just only divide by 12 and you get the wrong sign. If you get the wrong sign, you get the wrong answer. So be careful about that. We're going to box and cross, and x is going to be equal to what? 7. Box and cross, x will equal 7. Okay, for our last one, we have 2/3, parentheses 9x plus 15, close parentheses, minus 2x is equal to 2. Do we have distributive property here? Yeah, we do. We can distribute. We can do 2/3 times 9x and times the 15. So we got 2/3 times 9x. We also have 2/3 times 15. All right, 2/3 times 9x. 6x. Good. 2/3 times 15. 10. Positive 10. Okay, what else do we still have for this problem, though? We still need to bring some other stuff down. What else are we bringing down? Good. -2x and then equals 2. So there's our new problem. Okay, we have 6x plus 10 minus 2x is equal to 12. Okay, combining like terms. Can we combine any like terms here, Tavina? Good. We can combine the 6x and the minus 2x. Okay, so when we do 6x minus 2x, we're going to get 4x. Okay, what do I still need to bring down? Positive 10 and equals 2. Okay, so we have 4x plus 10 is equal to 2. What are we going to do first? Rajay? Okay, yeah, subtract the 10 from the 2, right? Subtract it from the 10 and subtract it from the 2. Okay, those can get boxed and crossed. We're now going to be left with 4x is equal to negative 8. And then our last step is to what? Divide, right? We're going to just divide. We're going to divide both sides by 4. And remember, if they're side by side, we go ahead and divide. So we're going to get x is equal to negative 2. All right, so we're moving on to translating. We are translating our word problems into our actual equations. So we're not going to really solve any of the equations today. I want to focus mostly on just translating from a word problem into an equation. So there's a few things that we need to make sure that we go over before we can start translating. We need to remember a couple of rules. So go ahead and flip your paper here. At the very top, I want you to write down the following, that when we're talking about a constant in a word problem, if we're focusing on a constant that's in a word problem, then we are focusing on, again, a one-time value. Okay? It might be a starting point. It could be a fee, things like that. These are one-time occurrences, or a position that we are starting from. And then we have our coefficient. When we talk about a coefficient, we are talking about the terms per, each, and every. This is something that occurs multiple times. And it's always connected to the variable. Your constant is always going to be affiliated or connected with your variable. And of course, when we now have equations, so we did this before, we did this with expressions, where we were setting it up as okay, we have our constant, we're going to either plus or minus our coefficient in our variable. Patrick, stop with the hair. Thank you. But this time we now have the added effort of setting it equal to something, meaning that we have to have an end point, something that we want to have as a stopping value. Okay? So when we're taking a look here at problem number 1, it costs $12 to attend a golf clinic with a local pro. Now you can buy buckets of golf balls for practice during the clinic, and they cost $3 each. You can spend $30 for the entire clinic. So we want to write an equation that represents how many buckets of golf balls you can buy at the clinic. Okay? So when we are looking here, we're looking at each of these values that we see. It costs $12 to attend the clinic. Are we paying this one time or multiple times? One time. It's $12 to go to that clinic. You just have to pay it once. $12, it gets you in. Right? Just a one-time fee. So this is going to be our constant right here. Okay, so we're going to, up front, we're going to pay 12 bucks. Now, you can also purchase buckets of golf balls to practice, and that's $3 each. Okay, that's $3 each. So we're talking about buckets that are $3 each. There's our coefficient. Our coefficient is going to be 3. We also happen to have our variable there as well. It's $3 for each what? Is it each ball? Each what? Read the question through. Each bucket, right? Your variable is going to be buckets. B. Okay, so we spent $12 to attend, to get into the clinic. We're also going to spend $3 for each bucket that we buy. So that's going to get added on to our cost. Okay, now the last thing that it says is you spend $30. So that means this entire thing that you've done here is going to be equal to $30. It's going to be equal to $30. That's your total equation, okay? Because this information right here is your end point. That is the final point you're getting to, is $30 cost. So that's what it equals. So there's your equation, that's it. And then you would originally just solve. But we're not solving today. We are just writing. So we have 12 plus 3b is equal to 30. Okay, taking a look here. We have Jessica wants to save money so she can buy tickets to a concert. The tickets cost $405, and she's able to save $45 each week as a dog walker. So we're going to write an equation that represents how many weeks W it's going to take her to save enough money. Okay, so let's go through the problem. The tickets cost $405. What does that represent? Is that a constant, a coefficient, or what it's set equal to? Ooh, we got a debate here. We have some people saying coefficient, some people saying constant, some people saying what it's equal to. So here's the thing. What is her goal in mind? She wants to save money so she can buy a ticket, right? So she needs to have enough money to equal the cost of a ticket. Do we know the cost of the ticket? Yeah, this is what it's equal to. So this is going to be our equals value. How much money she needs to have in order to be able to purchase the actual ticket. So when we create our equation, this is what it's going to be set equals. Okay, so now we only have one other value, the $45. It says $45 each week. So the fact that it has the word each means that this is a what? A coefficient. Okay, the fact that it has the word each means that this is going to be a coefficient. And in fact, we know our variable already too, weeks, right? It even tells us weeks is W. So when we write this, coefficient and variables get written together. They're side by side. So 45W equals 405. She didn't have any money saved up yet, so there is no constant. We just have how much money she plans to save every single week until she has a total of $405. Okay? Any questions about that one? Okay, it's not always going to be a constant. There might not always be a coefficient, but there always is going to be something that you set it equal to when we're writing an equation. You always have something that you're setting it equal to. Okay, let's take a look at problem number 3. Paulo has $145 in his savings account. He earns $36 a week mowing lawns. If Paulo saves all his earnings, after how many weeks will he have saved $433? Okay, so what is the final amount that we want to have? 433. That is what we want our whole thing to be equal to. So right off to here, this is going to be our equals. Okay, so we know it's set equal to 433. Okay, so let's take a look at the rest of these. Paulo has $145 in his savings account. He earns $36 a week. Which one of those is a one-time starting value? Addison? So he started with $36?
Oh, no.
He started with $145, right? He started off with $145, okay? This is a starting point. That's our constant. So we're starting with $145. Now he's going to continue saving. So if he's going to continue saving, are you going to add or subtract? Add, right? If you're going to continue to save money, you're going to add. Okay, now I know it doesn't say per, each, or every, but could I replace the word a with per? Could I say he earns $36 per week? Could I say $36 each week? I could say $36 every week. You could replace the word a with per, each, or every, then that's a per, each, or every word. Okay, so the fact that it says say this could be a per, an each, and every. Okay, so there's our coefficient, $36 per week. What kind of variable should I use? What letter should I use to represent week? W. Weeks, dude, weeks, W. Okay, $36 per week, or each week, or every week. Okay, all right. What I want you guys to do is you're going to do problems 4 through 8. Again, you're not solving, so it should not take you that much time to go through them. You are not solving. You are just writing the equation. Okay, so for problem number 4, it says Kelsey went to the mall to buy some new clothes. She spent a total of $140.49. So right there, the fact that they're telling us the total, that's our equals. When they tell you how much they spent totally, oh, sorry, yeah. That's going to be our equals. Okay, so we're setting this equal to $140.49. Now, when she did this, she bought 1 pair of jeans and she bought 3 shirts. We know the price of the jeans, and since it happened to say, hey, she only bought 1 of them, then that again means that this is a one-time purchase. It is a one-time purchase. She bought 1 pair of jeans, plus she bought 3 shirts. Do we know how much the shirts cost? No. So that's not $3, that's 3 shirts at X amount of dollars. It's an unknown cost. The fact that they're wanting to know how much were the shirts going to cost, that means the shirts are going to be your variable. Your shirts are going to be your variable. The cost of the shirts. How many shirts you purchased is your coefficient. Okay, so you should have $54.99 plus 3x is equal to $140.49. All right, go ahead and switch it on over to the next. All right, Juan's cell phone company charges $35 a month for phone service plus 50 cents for each text message. We want to know how many text messages can they send in a month. So we're only focusing on the cost for 1 month if their bill was $52. So what are we setting it equal to? The $52, right? $52, that's our total end game. That's what the bill is going to be. That's our equals. That's how much it's going to be equal to. Okay, what's our one-time charge for the month? Just, we're going to have it happen once for the month. Addison? 35. For that month, we're only paying $35 one time. And then on top of it, see that says plus, we're going to get 50 cents for each text message. 50 cents for each text message. So I'm going to put 0.50, and you could put T or you could put M. M's a better one, message, instead of T, because T looks like a plus sign, doesn't it? Okay, there's our equation. $35 for the overall charge, plus the 50 cents for every message, and that's going to equal a bill of $52. All right, Northbrook Middle School soccer team purchased uniforms and equipment for a total cost of $912. The equipment costs $612, and the uniforms are $25 each. So how many uniforms can the school purchase? What are we setting it equal to? The equation is set equal to what, Jacqueline? $912. Okay, our total cost right here, this is our equals. That's what we're setting it equal to. Oop, I forgot a U in there. Ooh, there you go. Okay. All right. So there's our total cost. What's the one-time purchase? What are we only happening to purchase once in this problem? Jaden? So the 25 represents uniforms. Do we only have one person playing on the team?
The equipment.
The equipment. You only have to pay for the equipment one time, right? Once you buy the equipment's there. But the uniforms, you have to pay for every single person that's on the team, right? So the equipment is a one-time purchase. That's our constant. Plus, we're going to pay for the uniforms, but we don't know how many. But remember, we have that keyword each. So we're going to have 25 U. That's for how many uniforms? All right, a plumber charges $75 to come to your house, just to show up. Plus, they're going to charge $25 for every hour that they're working. So how many hours did a plumber work if they charged you $200? Okay, so what are we setting it equal to? What's our total amount set equal to? Sabina? 200, right? That is the total charge. He charged us 200. That's what it equals. Okay. What's our one-time cost? What cost is he charging us just one time? Rajay? 75, because he comes to your house just once, right? It's not like he's going to come, leave, come, leave, come, leave. He's not going to do that. He's going to show up to the house one time. So that's our one-time charge. Okay, plus he's going to charge $25 per hour. So there's our coefficient, 25. What variable do you think I should use? H, right? Because it's for the hours. We want to know how many hours, so H would be a good representation for hours. All right, number 8. The fare costs $12 to enter. If you want to ride the ride, you got to buy tickets. Each ticket costs $2. So how many tickets are you going to purchase if you spent $62 at the fair? What are we setting it equal to? What are we going to set equal to? Jaden? Yep, 62. You spent $62. Who was that? That was you? Did you say 62 like that? I thought that was somebody else and that you were getting annoyed, but okay. It was a little creepy. All right, so you spent 62. That's what it's equal to. What's the one-time price that we have to pay? We only have to pay it once. What is that going to be? Kaylin? $12, right? You enter the fair. Once you enter the fair, you're in. You don't have to pay it again. You've entered the fair. You pay $12 just one time. But now you want to ride the ride, so you got to buy tickets. How much were the tickets? $2. So $2 per ticket. I'm just going to put X for tickets. We're going to put X for tickets because T's look too much like plus signs. All right? So there is our equation for that one. Okay, you guys have a Wayground. It's just 12 questions, and it needs to be finished before you leave. Is that understood? Did you hear me? When does it need to be done by? Before you leave. Jaden, when do we need to have the Wayground done by?
Before you